Hello everybody, welcome to today's lecture. This lecture is about galaxies and we will learn many things about galaxies. So let's see the outline of this lecture. First of all, we will study the family of galaxies, the discovery of galaxies. We will see what types and what shapes do we have in galaxies. We will do a survey of how many galaxies in the universe. Then we will see some calculations and for some properties of galaxies, such as the distance of galaxies, and we will study Hubble's law and how can we determine the distance of a galaxy using Hubble's law. Also, we will see how to determine the diameter and luminosity, the mass, and then we will see the supermassive black holes in galaxies. We will discuss this, and we will discuss the the dark matter in galaxies. By the end of the lecture, we will be studying the evolution of galaxies, and we will see what are clusters of galaxies and colliding galaxies, and the origin and evolution of galaxies and the farthest galaxies. Galaxies are star systems. They are a group of stars, of millions of stars located in a single huge thing like a cluster, and those stars revolve around the center of that system, which is called the galaxy. And galaxies may have something called black holes in the center that causes stars to revolve around it, and we will see what are those things called black holes, and there will be a whole lecture for black holes. They contain a few thousand to tens of billions of stars, and they have large variety of shapes and sizes. Okay, so this is a photo taken by Hubble Deep Field, and it had an exposure of 10 days. An exposure is when you leave the camera till its sensor can feel the light and make the photo clear. So here's the sky full of galaxies. It has galaxies everywhere, and galaxies have many shapes, such as spirals, ellipticals, and irregular. And of course, galaxies are very distant from our Earth and from our solar system, because they are already very distant from our own galaxy. Okay, let's study the galaxy classification. For elliptical galaxies, we have spherical galaxies and elliptical ones. So the indicator for the elliptical property is determined with a number from E0 to E7. So the higher the number, the more elliptical it is. Okay, and we have also another kind of galaxies, which is spiral galaxies, And spiral galaxies are either having large nucleus tightly wound arms. The arms are so tight and not moving away from the center, from the nucleus of the galaxy, or with small nucleus and loosely wound arms. And the number or the letters identifying this is determined as S for spiral and A, B, C. So A is large nucleus, tightly wound and arms, and C is small nucleus, loosely wound arms, and B is moderate. Spirals are rich in gas and dust. Spiral galaxies are always rich in gas and dust, while ellipticals are almost devoid of gas and dust. Not much gas and dust. We have another type of galaxies which is called barred spirals, and the barred spirals are spiral galaxies, but they have a bar coming from the center. So as you see, this is the nucleus of the galaxy with a bar here in these two sides, and the spiral arm is coming out of it. So it's a bar and arms. And when we the term for these galaxies is S for spiral, then B for barred, then A, B, C, and so on, for how loosely the arms are. And there's another type of galaxies called the irregular galaxies, and they are often a result of collision between galaxies and merging of galaxies. And they have very high activity for star formation, starburst galaxies. So these are the types that we were talking about. Okay, we have a way to find the distance for the galaxies. We can use the Cepheid method, and we discussed the Cepheid method before. We can use the Cepheid method using period luminosity relation for classical Cepheids. Measure Cepheid's period, find its luminosity, compare to apparent magnitude, and find its distance. Okay, using Cepheid's method, it's to observe the variability of the celestial body, and from the variability you can get the absolute magnitude or the luminosity. So you get the luminosity, the absolute magnitude, and you have the apparent magnitude of that galaxy, so we can have find the distance with the law we discussed earlier in previous lecture in the family of stars. You can find it on YouTube. Okay, another way is type Ia supernova. Collapse of an asserting white dwarf in a binary star systems. Type Ia supernova have well-known standard luminosities. So when you have the standard luminosity, you can get the apparent magnitude and find the distance. So it's always both are standard candle methods: know absolute magnitude luminosity, compare to apparent magnitude, and find distance.